And today I'm here to talk about a new direction we're heading in, and that's specifically this new project we've kicked off called the Web of Trails. And in some sense, though this is not new to me, for those of you that don't know this reference here, that's Chris Elliott in the movie There's Something About Mary. In that movie, he discovers that an old flame of his that he's been very passionate about has been located, and he breaks out in hives. So when DARPA put out a broad area announcement that cited Memex, I did much the same, and I started babbling about, okay, well now we're going to just go back to this idea, and we're going to enumerate everything, and we're going to build a giant semantic wiki about it, and so on and so forth. And at some point, some of what I said stuck with my co-founder.
What's Memex?
Okay, so sorry about that. For those of you not in the know of what Memex is, Memex was originally an idea presented by Vannevar Bush in an article in Atlantic Monthly in July 1945. And in it, he really kind of articulates an idea for an information appliance that would help us manage, that would become an extended memory. So much like we use computers to do math for us now, we would be using something like a Memex to at least index and structure the things that we do know. So for instance, like a guy like me, I'm actually, I think we're all cyborgs at this point. Because in some sense, I know what I know, but I actually don't know. I know what I can know, actually, is what's going on. I have a large amount of information that I keep online, and I'm constantly doing loop-de-loops through that information, paging it in, updating it, and then paging it back out as I go to work on the next thing. And Vannevar Bush kind of gets at the essence of this. Of course, he was really talking more about, has anyone here not used a card catalog to find books? Okay, great. So we're already getting to that point. But one of the points that Vannevar Bush had is that when we're kind of indexing data, when we catalog what we know, in some sense, the way it was originally done is we kind of have this index, and we go in there and we find the book, but then we have to kind of go back out. We go get the book. We look at what the book cites, and then we have to go back to the card catalog. And this isn't really how we think. So to get to the chase, the human mind doesn't work like this. It doesn't kind of begin anew. It meanders through this web, and it becomes a web of trails. This idea of bumbling around from ideas that are all interconnected. Apologies to James Burke. Great. So, what is Web of Trails? So Web of Trails is us trying to apply some of these ideas that I've had about the Memex information appliance to the domain of search. So really kind of where we're at in terms of what we're doing with search is we're on the left-hand side, and I think what we're really trying to do is we're trying to get to the right-hand side. So on the left-hand side, we have lexical search, where we kind of give some keywords or terms or things that we think might be related to what we're trying to find, because we don't even remember what we were trying to find. And so what ends up happening, though, is we're asking the computer to find what I say. Go find things that say what I just said. What we really want the computer to do is to find what I mean when I say the following. And kind of as an intermediate step, what we do is we're trying to get into this realm of syntactic search. So whereas I may still not where the question will then become, don't look for what I say, look for things that are structured similarly to what I say. So let me say that again. Like when I say a word, that word has a word sense, and then it also kind of has a way of fitting into syntax. And so I can go find that word out in the literature. I can find where that word appears in the syntax of the document. And then I can also ask the question, what other words sit in structurally similar positions in other documents? So, you know, this gets into this realm of, well, okay, so we have these bags of words, and then we have experts input their relationships. So maybe we're using something like WordNet in the first case to get us to kind of limit what we need to describe what we know about a word. But again, I think it's a whole new world that we could go into if we start using those two things again to look at this idea of structural similarities between documents. So I just kind of wanted to briefly tip my top hat to this is all built on top of a bunch of other really wild ideas. The first instance I've heard of enumerate every idea possible and then start building catalogs of interrelationships between these numbers. Dates back to René Descartes. I'm not going to put Leibniz on there because I speak English. Of course, Vannevar Bush and his idea of the MEMX, this information appliance. I'm going to put all the things that I'm interested in into it, and it's going to be able to keep them. It's going to be able to know what I know for me. Ted Nelson is actually, for those of you who don't know, was kind of the idea, the guy that came up with the idea of hypertext. And then, of course, the same DARPA BAA mentioned the mother of all demos, where Doug Engelbart just went and blew a bunch of people's minds. All right, and then, of course, but we didn't have anything terribly actionable until Tim Berners-Lee was actually trying to solve the same problem. He worked at CERN, and they had a lot of physicists talking and whatnot, but you know, they didn't have good indexing of the email archives. They didn't have. So in some sense, they didn't know what they knew, and there was a lot of wasted effort. And so he wanted to create a way for people to kind of build these knowledge repositories. And I think Ward Cunningham deserves a mention here, where I think in some sense he's been kind of forgotten, and that's just sort of fallout of the success of Wikipedia. But Ward Cunningham invented the wiki, which I think really delivered on the simplicity that Tim Berners-Lee wanted. Like, Tim Berners-Lee got something working using a complicated stack of technology, and Ward kind of cut to the quick of it, in my opinion. So I also wanted to give a so as we're trying to move to this idea of of syntactic search, what we're really kind of doing is we're introducing this idea of grammar into the semantic web, and I think the semantic web desperately needs this effort because RDF and OWL are really a pain in the butt to write by hand. And so I would point to, this is Tim Berners-Lee on the left and Paul Klint on the right. Paul Klint kind of outlined a whole stack of syntax-related tools that we don't have time to discuss. So let me quickly talk about grammar inference, where we've been playing with an algorithm called Sequitur. You can find out more at that link, but basically what happens is it's looking for repetitions in text. And what it does is when it finds a repetition, it creates a production in a context-free grammar. So what we're looking at here is we're looking at how this string of babble becomes a context-free grammar. And one of the properties of that context-free grammar is that it's not ambiguous. So there's only going to be one parse for an input. And then this of course results in a parse tree. And so as you can see, and we can represent this whole document has two non-terminals as long as we have the rest of this information. And so it also has this kind of compression aspect as well. That becomes more important in search because we are trying to index information. Information's growing faster than we can actually build out storage to index it, because index is in a different space complexity. And so this compression really, I think, is going to give us a way of managing the space complexity of indexing. So I just wanted to hit on some just again, to keep this completely ambiguous, I'm going to just hit on these themes. Some things that I really like are simplicity, parsimony, and serendipity. I think this to me kind of sums up why I use the web. Things should be simple. And furthermore, it should be easy for me to find when I'm repeating myself. But in terms of parsimony or finding synonyms in the literature, I should be able to find when I'm thinking somebody else's thought already. And how do we do that? Because people are going to use different words. We're going to have different jargon to talk about the same ideas. Like somebody in the social sciences may have invented one thing. Let's see, a good example in computer science is the type isomorphism and how it correlates to logic. So you had these two groups. You had logicians thinking about the same thing as type theory, as people who implemented programming languages several decades later. And things could have been much better for everybody had the computer scientists known about the work that the logicians had done beforehand. And I think that in terms of figuring out who's thinking about what, this creates kind of a serendipity where I can I can basically again just bumble through a semantic web, but also have it reach out much deeper into the literature than I could just with using my own brain. And this serendipitous experience of discovery and rediscovery becomes a joyful thing rather than oh my gosh, I'm never going to think a new thought again. So let me segue more to the topic of the panel. This is actually in our message of the day on a server we use daily. I added this as a joke. This is before the Snowden leak. But I think it really gets to some ideas that are related to this MEMX idea in a completely weird way. So I was at FM10 in Chicago in May of 2006. For those of you that don't know, First Monday was one of the first open access journals. It's free to read, free to submit. And they were celebrating their 10th anniversary. And I was, they were gracious enough to accept a paper I wrote that kind of expounded upon all of these ideas in more depth. I hope y'all have the time to see that at some point. But one of the bombshells kind of drop on this openness pajama jam was presented by a professor of communications at the University of Wisconsin, Milwaukee, Sandra Brahman, where she talks about the politics of openness in the construction of memory. I'm not sure I'm not sure I'm versed well enough in philosophy to understand how this relates specifically to memory, but I have thought about, I have heard that term used a lot this week, and I do think it's important. I think it's important because it goes back to that cybernetic relationship where my memory, what I consider to be my memory, is actually much larger than what I actually have in my head at any one point in time. But that becomes, like, if you can control my ability to get access to the data, then you actually begin to affect how big my memory is, which is an annoyance. So anyway, these things kind of threaten the idea of being open. We want to be open, but there are some things we actually do want to keep closed. So what Sandra kind of talked about was that the panopticon becomes the panspectron. And what that means is that in the panopticon, there are lots of one-way mirrors. People can watch you that you can't see back. But now we're actually putting computers behind that. And the computers are looking for abnormal behavior first. And then they flag abnormal behavior to actually have a human. So to have a human say, okay, well, now I can make the semantic call as to whether or not this person is behaving badly or not. And one of the tactics Sandra brought up was beating the hidden Markov model. The idea there was that you could behave in a way that ran out farther than the classifier that was watching your behavior. So the idea here is that you have a behavior as language, right? So like for instance, a very simple one is, you have a day is a sequence of days, and that day consists of sleeping, eating, coding, eating, watching Star Trek, sleeping, and then but you can kind of create a grammar that expands and contracts that based on as things arise in the day. And then any deviation from that grammar then can be kind of flagged as, this is interesting behavior. This is something I haven't seen before. So we're not just building models of language using natural language processing technology. We're building models of behavior. To make things worse, even if we're de-identifying data, any behavioral record is potentially identifying, and that's because it's not hard to correlate certain things that you know about the data you're seeing to other databases of information, other information sources, and then kind of retag within some certainty who a person is. And so here are some things to help, and here are some links to click. Thank you.
So why don't we're going to move some chairs.